Please, good morning, my students. Morning, it's not afternoon. So see here, if you are with your graph on compound pendulum, I want us to do it this morning because I noticed most of you, the readings, even the parts where you people are answering what does it represent. The number of things people are writing, you're just writing what on that. First of all, they told us that our meter rule has the center of gravity, and they gave us is it 50 centimeters? You know what they gave it? And you need to know that the center of your meter rule, guys, half of your meter rule, that's what gives you the center of gravity. That is the balance point. So that means that the total length of the meter rule used is going to be 100 centimeters. I see it? Yes. So your length L is 100. So the total length of that meter rule, the length of the meter rule is 100 centimeters. So still remember that what we are doing is compound. Alright. Now that I have this, I'll tell myself, first of all, what is compound pendulum? What is it all about? We've done simple pendulum and notice that simple pendulum has to do with rope and the ball. Should it? Yeah. But when it has to do with compound pendulum, most of the practical is done using the rigid body. In most cases, for your level, you use ruler. So what they do is when you have that your record stand, you come and attach ruler to it. And that ruler you're going to be attaching is already graded, like there will be opening beside it. And each of the opening has distances. Yes. So when you come now on your resource stand, let's say I come now, have this my resource stand, I come and put this meter to pass through the pin. Now when it passes through the pin, as it's hiding, if I now push it, as it's moving, I can't show you your station where I can't take it. That is how it's done. So when you finish it, you shoot at this particular part. When I calculate this is 5, this is 5, 10. So when I put it here, I switch it, I take that. So this is how the percentage is done. So whenever I tell you ropes, what does K represent? What K represents is actually your axis, your meter rule axis of direction. K represents all those rules that you come. So not just meter rule. I noticed when you are writing meter rule, it represents the meter rule axis of direction. Alright. So that's why it's this right here. So now let's progress. Now the next thing you need to know about that K itself is that the axis of direction of K for any object is given by the square root of the moment of inertia all over mass. Please pay attention. It's given by the square root of moment of inertia all over mass. And we know that moment of inertia for any body that starts from the center is given by ml squared all over 12. When you carry this, please, as you are entering, you settle down, no noise. We are not here to discuss. So, if I carry, I say the moment of inertia 9 is equals to ml squared over 12. So, if I know this, if I carry this moment of inertia to the value of 9, what I say is equals to root ml squared over 10 times 1 over n, because this is delta, and this is delta, say, moment of inertia times 1 over n. Are you aware? So that this is square from NL square over 12N. This will take care of this. Then square will take care of this particular range for this one upstairs. So this is like I say 12 then this. So K will simply give me L over root 12. So this is the formula for your K, which is axis of gyration. K represents meter root axis of gyration. G-Y-R-A-T-I-O-N, not meter root. Gyration. I already explained it. Pay attention, not when you just look up and ask me. I said that the meter root you use for this practical is always in a way that it is already punched or should I say the space is already created inside it. And this space is created inside it as spaces that you mount on the record stand. So, and I said that each of these spaces now, that's what your J represents, the axis of gyration. I said that when you clamp this under your record stand, if you come here and use for the first one, let the pin pass through it. As the pin is passing through it, and it's hanging, it's there, then you push it to move. As it's swinging, you take it. When you are done with it, you can now push it up so that it's no longer here. So now make this to you press it up so that you can come up. Then let's say this becomes the second one, you put it inside, push it again as it's swinging, you take the lead. So if I know that, the first thing I want to get is my K. I notice that in your notebook, you people have so many values for your K. Is it not true? But please, the normal way to find K is simply the total length of that ruler. That is what this L represents. All over 12. And total length of the meter root is 100 centimeters. And 100 centimeters is given to 1% as what? Meter. If I divide 100 by 100, what will I have? 1 meter, should be? Yes. So if I want to do this case, I can use this, or I can use, and I can use meter, I can use centimeter. So I'll say J is equal to 100 all over 12. And I punch it for me. Notice that this is 1 centimeters. So punch 100 over 12 for me. What do you have? It should be giving you around 29 or thereabouts. Just check. Eh? Okay, it's giving you 28.86, okay? Which is approximately 29, right? In centimeter. And this in millimeter will be 0.29. Is it not true? Do you know the same way? The same way you have G to be a constant. Should you know the same way you have G to be a constant? That is the same way as this K is a constant. For any meter rule, provided you know that the meter rule, the length is 100 centimeters, the value of K is also a constant, 0.29 meters. Now, using this now, even without doing the practical, but I believe you'll be giving you this, right? But you know that in our class, we normally say whatever reading you have, the best way to confirm if you are correct is simply using the equation of compound pendulum. And compound pendulum has its own equation. Simple pendulum has its own equation. And the equation for simple pendulum is given by T equals to 2 pi with L over G. Is it not true? While compound pendulum is given by T equals to 2 pi with unity H square plus all over G net. Is that what they gave you? So if we are able to use that equation and solve, please, those of you who know, I have to say it here for kind. Notice that that camera is here so that we can record this class and post on the group. So don't go and fall the camera down. Those of you now, you do as if you did not see it. Then you're telling me sorry. Yes. So we've got to call it for K. Now please, let's give me the equation. Can you do this? No. When I try and give me the equation for that compound pendulum, then you give me all the roots you have there. So Z equals 2 pi F, then root of H square plus E square all over G and Chevy. Why I said bring it out, we already know it was so that we'll be sure. So that at the end of the day, everybody say we use your own formula. No, this is the formula for compound pendulum. And once they tell you compound pendulum, it simply means that you are now using a rigid body. Yes. You know that thing we normally use for simple pendulum, that's what we normally use. It's not really rigid. So we use rigid body. Once it's talking about it's no problem. Alright. So let's now try to get our readings. Oh, please, someone should help me with your practical and let me write out all these steps for compound pendulum. So I also said that you need to note that once you walk our meter rule, that the length of meter rule is always there, and that the center of gravity is always the center. S N. We have 1, 2, 3, 4, 5, 6, 7, and 8. Then we have one that gave us 5. Please, remember we said this is a constant. This is our length for that value. That's what we use to find it. So, but they gave us when days 5, when days 10, when days 15. Please, be telling me what we are writing is to do for your own. And they gave us small keep on that. They gave us they gave us then they gave us hedge. They said that S minus CM. Then they gave us S square, CM square. Then they gave us H square, CM. Alright. So at the end of the day we have okay, let's just pick one after the other. Well, let's start with Peter. This is just what I need. I'll stick all the back for this. Alright, so we're trying to analyze this. Now, see, I know that this is time for 20 oscillations. Are you aware? Time for 20 oscillations. But this one is time for 1 oscillation. Are you aware? That's what period is. That is why another formula for period is simply T equals for anything that has to do with periodic motion. T is equals to time for the number of oscillations, not the number of oscillations. This is constant formula for anything period. This one can change depending on where you're going. Notice that all of this simple pendulum. This is not the formula we use. But it is always constant. Alright. So now to find period, I can say at each point, we now find at each point T equals to 2 pi is set as saying 3.143, should it? Yes. 2 times 3.143. Then root. The first hedge given to me, when this gate is 5, what hedge, which hedge is the first hedge? The first hedge given to me. What did I as hedge here? 45. 45. Okay, they gave me that hedge is 45. Okay, that means I'll have 45 squared. Then, because I got my gate to be 0.2. Please, this 45 is 6 centimeter. Okay, it's in centimeter. Okay, that means if I'm going to use this in centimeter, I will also use The value of my K is centimeter. Do you remember? So, and this is 29 centimeter. So please, at the end of the day, we should be able to use any value we get to solve, and our G should be equal to 9.8. It's very important. That's also correct. So that's 29. All over. But notice that if we use this in centimeter, that means our G, we are no longer going to use 9.8. Because 9.8 is a meter. Okay, no. So when I do 9.8 times 100 is what? That's how we are going to use. 9 days, 9 times our head. 5. I have punch for me. Yeah? They are missing now. Punch for me. 2 times 3.143. Then take the square root of 45 square plus 29 square all over 980 times 45. Whatever you have. Nice. Okay, 2 times 1. And then the square root of this. Nice. You first of all do 45 square. Do 29 square. Add it up. Then do 980 times 45. Then take the square root of what you have. What do you have? That's supposed to be the problem. What do you have? Please, those people there, what are you people doing here? Good job. They have already covered this place with the blood. They have prayed for us. I have what do you get? Taking the square root of 45 square plus 29 square divided by 980 times 45. Please, even if you've done this, calm down and work forward so that you will compare it with your answer. Everything you're going to do here must be correct. So that when you are checking your owner, you are checking what is missing and you'll be sure. Then now, but then now, what are they doing on one side? But see what you put 45 square. See, 45 square is what? 2025. But 9 square. 8 4. The next square is okay. Now 980 divided 980 times 45. I'm taking a punch and you got what we are. Like this? Okay. Now they are not done. The square root get 0.5. Like this. And please, this is the second shilling. Please remember that the values we are using, we move everything to centimeter. Do you remember? Because they gave us centimeter. Yes. That's why they normally advise you to use the SI units, which is meter. But why we are using centimeter is because they gave us values in centimeter. So what's in mind? Okay. So I'll come and put the first thing here to be 0.25. Please, will I write seconds here? Will I write seconds here? No, Sherry. So please, one thing is make sure you don't repeat seconds or repeat the unit. Once it's written up here, don't need. Alright. So that is for my first period. Time for just one oscillation. I've gotten it. Now there's something I want us to do. I want to do this. Please, you have to be active so that we'll be fast. Anything like God's spirit or spirit of you are not supposed to participate in the movement for yourself. So when you use 981, Chevy, 98, we did, since this is in centimeter, not meter, this is in centimeter, not meter, the 9.8 for gravity is actually in meter and seconds. So we now convert that, yes, now convert it to centimeter. Okay. Ask. Okay, what we got here? We did not place it with this. Yes. We are placing it. Thank you very much. We are placing it 0.25 times 6.286. That's why I said we'll do this together. So, as we do it together, we must observe. So, what we have as our square root now times 6.286. I have watch. We have the ability fast. 6 equals to 1.5715. Okay, but 6 into 2 decimal place. So this is the second. So this is actually 1.57. And please, once we are using 2 decimal places, we maintain it. So that is for our team next video. So I want to click. Let's do this for the second one, which is the second height. The only thing that is going to be changing here, is our edge. Can you see this? That's what will be changing. So please, when you look for the second height, what is our second height? Hope you know how we got our edge. So what is your edge? The second edge, what is it? 40, should be? So if I have that report, I have T. Some people are looking at us like we are getting what we are doing. See, you are okay, that's it. They think you look for G. I know that we will look for G, but before we look for G, we have to get our readings. That's what we are doing. We are getting readings, Chevy. You want to get G so that you quickly come here and enter your notebook. Don't worry, we'll move to that part. Now let's just find the second one. We'll now move to that part. So get here and there. So that we don't waste our time. And I see it's equals to, please pay attention. Watch. I have 2 times 8.143. Then root 40 square plus 29 square over 980 times 40. Oh yeah, this is my K, and we already gave the formula for K. So now please punch this for me. What we have. Do everything and give me the final answer for it. I just want to show how to get that one line and the other one. Yes, for those of us that didn't do the practical, even if your lecturer, assuming your lecturer did not even give you the readings and they just gave you the practical like that. So we are trying to get it without even doing the practical, and this one is always correct. Alright, so please watch everything here for the one here. That's using our edge. So our first, please watch. 60. That's for everything. Hope you know how we are getting this edge. They give us S is our center of gravity, right? And it's 50. Is it not true? So by the time we check this stability to us, all this stability to us, we are subtracting. We are simply saying that 150 minus 5 will get 45 for the first one. And that is the edge we use. We also do a day for the second one. When 50 minus 50 is 10, it gets more. So that is how we want to do it. So please, after this one now, we now solve all those questions. But I just want viewers and people to actually be for those of you on WhatsApp. So when you check it, so that they see how to get to this, even without being practical. Alright, please, what everything here for me? Just give me the final answer. What's the final answer? 6 equals to 1.57, like this? I'm going to 1.57 seconds. So please, watch this away. Because what you're doing now is the same thing we have here. So make sure you are correct. We're using 40 square. We're using 40. So what? Check. What did you get? The power T, the period. Yes, I saw everything on that place. 1.57. So we still got 1.57. I'm wondering how soon. Go 1.47. Yes. It should be more correct. Yes, so please, now we've gotten this. Please, whatever you are doing, even as you have your readings, this is the most correct way of getting your readings. Because this is simply using the equations of compound pendulum and then knowing what K is to find your readings. So that is how to do that your reading in case you didn't do the practical work. Initially, I was started with the result to do the practical. So now we are going to move, then we'll finish T1 and T2 to answer the questions of that graph so that we can find G must always be constant for the 9.8 so that we can find K. Then we can find all those intercepts at the rest it has to have. So we've gotten 1.47. So assuming I'm to find this T1 and T1 and T2, what I'll just need to do is to simply say naturally time for one oscillation is equals to time for 20 oscillations all over number of oscillations. And I'll have that this is for the first one T is 1.57 equals to time for 20 oscillations. I did not do the practical, I'm not inside the practical, so I'll just say this T. I don't know it. I know how to get that for one oscillation. The number of oscillations is 20. You know what is given in the graph? 10. Since it's 10, I'll use 10. Very important. If they say 20, if they say 50. So since it's 10, I'm using 10. So by the time I do cross, next is standing over this over 1. So this will be the same as saying T is equals to 1.57 times 10. So I want you to have what? 15.7. So I will do 15.7. But remember, we are maintaining 2 decimal places. Is it not true? Which means even this one I should have 0.00. 0.00. You remember, I will maintain 2 decimal places. Please remember I told you that once you are using 2 decimal places to maintain it, if you are using 1 to maintain it, very important. These are things that look at when it comes to the graph. Very important. Some people will say it doesn't matter. It matters. So this is 15.70. Assuming I want to look for the second one, I will simply do, this is 1.47 for the times, the place 6. So when it times, you have what? 14.70. See that? Now please, if you want to get this to please, if you want to discuss here, hello, if you want to discuss please, no noise. Let's do it. Now to get T2, what I will simply do is to simply say, what is the standard error in my T now? I'm using 2 decimal places, really. And I'll just say 15.70 plus 0.01. Assuming I use 1 decimal place, I will add 15.70 plus 0.1. And when I use 3 decimal places, I'll do 15.70 plus 0.001. So add it up for me. You are going to get 15.71, shouldn't it? So So to get t to do 14.70 plus 0.01, you are going to get 14.71. Is it not true? Yes. This is how to get t. Even if you did not do the practical, then you can obtain your values. And guess what? Whatever value you obtain using the formula, the way we are doing it, will even be more correct than what you're doing in the practical one. Because this is something that has been done, proven, before they gave you that formula to compound pendulum. So once you are able to use it to find time for one oscillation, you now remember that time for one oscillation has the practical formula, which is equals to time for 20 oscillation, or time for number of particular number of oscillation divided by the number of oscillations. That is all we need to get T1. Then when you get T1, to get T2, you don't just get T1. You actually use the standard error in time, which is just from the number of decimal places used. That's all we need. So you get it. Now to get your mean will simply be sum these two up, then divided by 2, because there are two things you are doing. So when I do 15.70 plus 15.71, whatever I give me divided by 2, to give you around 15.71. Is it not true? Yes. So let me just do T1 plus T2 all over 2. So for this one, you should be giving me, let's do T is T1 plus T2 divided by 2. So it should be 15.71. It should be 14.71. Alright, now my hair square. To get my hair square, we'll simply say 45 raised to power 2. 40 raised to power 2. And that is how I will do it for others. Raised to power 2. Whatever I give you 45 raised to power 2 is what? Please, you need to be sure. When you need practical, we need to watch it. Sure. Oh yeah. Watch for me. 40 squared. 1600. Oh yeah, see. Do you know that if you want to make this easy for yourself, then you just see. First of all, this is my Chevy. Is it not true? This is my T. To make this easy for yourself, before being here T squared, I will advise you first find T squared. Then, if I do because I know that this is second square, and I know that this one will be second square. So like, you see your old there, you do not grab your units. They comment your units. So this square now is the same as 1.57 square. What do you have? 1.57 square is what? That's 1.57 times 1.57. What do you have? 2.46. I am going to 1.47 times 1.47. 2.16. Ahead. Do it the same way for everything so that you get the last part. Okay, I'm understanding this. Ahead. So at this point now you can now say this is H, this is T squared. So you just do the value for H and the value for T squared. By the time you multiply it, you get your T squared. Is it not true? Yes, it's true. I agree for me. 45 times 2.46. 110.7. Some of you that have fine right to see what you will come and be doing. Some people will come and be doing for me like this. Centimeter, second, square. This your unit. You only put it once up here. It does not come down here. Don't do anything. The only thing you will take is maintain the decimal point. So nothing that this is 0.7, I must put 70. I do for me. And notice, this is 2025, should be. I'll still maintain 0.0. 0.0. It's important. Watch for me. 2.16 times H, which is 40 here. 40 times 2.16. 86.4. So as students, what you do for me is, in as short as you already have your reading, to have it in mind that what you're doing is very far correct. So you try to get the remaining readings using the same approach, the same method for everything. So once you get it, you must have value for everything you're doing. Now, I want us to quickly go to the first question here. What's the first question on that? Okay, they say graph of H squared. Graph of H squared. Or is it H squared? Against H squared. second square. And this one is the centimeter square. Is it not true? Please, this thing tells you something. Let's check something. That means that we are plotting a graph that is the inverse of acceleration. See, let's check. Because we know that this thing means y-axis against x-axis. Which means centimeter second square against centimeter square. So, and we know that the slope we have here will simply be centimeter square all over centimeter second square all over centimeter square. Is it not true? So when this cancel one of these, I will have second square over centimeter. And you know that whatever we have in centimeter can actually be converted to meter. You are aware? This thing is the same as 72 meter. When you convert it to meter, you have meter. Then all over second square. Why am I converting to meter? Because meter is the SI unit of anything that has to do with length. If you check this thing out, if you check this thing out, you see that it looks like the inverse of acceleration. You see that? So if they ask you, a question asks you, what does the slope of your compound pendulum graph represent? The slope actually represents the inverse of acceleration. That is what we have here. So if I know that that is the first thing, so please, you are going to plot the graph. Remember, we are trying to answer the questions on this side. But make sure you have this our limits plotted out. Whatever thing you have, you're coming. Whatever thing you have, you will be very far correct. Now, give me the second question again. Okay, they say you should determine the slope of your graph. Okay, let's say you plotted your graph, you have your own slope, right? But let's use the equation to see if you can determine the slope. Are you seeing it? Let's try to use the equation of this compound pendulum. Remember when we did simple pendulum, we also use the equation to determine the slope. So I want to play this. Let's see. So I will have Z is equal to 2 pi root x squared plus a squared all over g. Is this not what you have? Now see, if I have this, I can say, since I have 2 here and I have 2 pi, I can say, take the square of both sides. Somebody wants to ask me, why are you not cancelling 2 pi? The reason is because I know that the slope naturally is going to be something of second square over meter. Is it not true? Which is 80 square over meter. So over h square. So I'm trying to get a situation whereby I will have 80 square over 8 square. Remember, everything here is not as 80 square over h square. So my business with this is, how do I make this equation to have 80 square over h square on one side and the other was the other side? That's just my business. Once I have it, let's write it down. Now, take the square on both sides. So once you are trying to get slope with the equation, that should be your business. That thing you have to do on this side. Then the other side should be the slope. So then take the square of this. You see that I have 3 square equals the square of 2 is what? 4. Pi square. Pi is going to be pi square. Please wait, I'm coming. This 9 is making at the bottom before lecture. So pi square. Now, if this enter here, it will cancel this. Is it not good? And so now I have x square plus a square over g n. Notice that everything is equal to 5. So that is the first step. Okay. Please have this in mind that our goal is to make sure that one side of this equation has the 80 square over n square. Very important. So I'll have, so even if without my graph, I can get it here. So I'll have z squared, I want to revise, equals to 4 pi squared h squared, then plus, yes, you know that this multiply this, yes, plus 4 pi squared k squared. And notice that it will now have the LCM, which is GH. Is it not true? All the log are saying, since we have this mathematically, it's not confusing. Carry this multiply this thing. You see that you have this one called here. You only multiply this to do the record. This one called here. At the end of the day, you have something like this. And we know that anything this way is the same thing as saying, see, what they see. At this point, I can say, since I'm looking for how to make head t squared over head squared come to one side. So my business plan is simple. I have GH here, is it not? Anything cross the equality sign. This thing can be defined as saying GHT squared equals to 4 by square h squared plus 4 by square k squared. So if I have this, notice that I don't have business with, unless I want to make use of it. But for now, what I'm looking for is how to have head c squared over head squared. So I can say, at this point, you can divide both sides by g. So that g will come back here. So I want to have left g here, but I don't want confusion. That's why I carry it all over g. You see that I'm considering getting head t squared one side. Is it not true? So I now have h c squared equals, this is the section I think, 4 pi square head squared over g plus what is that? Plus 4 pi square k squared over g. Do you agree that these two things are the same?
Yes.
Yeah, really?
Yes.
Please, once you are doing anything equation of an experiment and you get that inside the square root or inside whatever there is a positive sign, it's important to always have this view in mind. Do you know why you must have this view in mind? Because every graph you are plotting has a standard equation, which is y equals to mx plus c. Alright, so if that is the case, it simply means that, what does that mean? Listen, I'm saying now, what does it mean? It simply means that, first of all, I've succeeded in getting this to represent the equation of the same line. Y equals to mx plus c. So notice that ht squared, do you remember that it's on the vertical side? And y is always on the vertical side, should it? I've succeeded in getting it to this. Then equals to 4 pi square h squared all over g. Now notice something. Do you notice that your h squared, when you plotted this graph, h squared is at x side, should it? So which means that this becomes your x, and everything here becomes your x. So this becomes your x. Now, it's always important, I said, once you see a graph, before you doing this, try to compare the situation from the other. So this thing, everything the other side becomes your intercept 4 pi squared k, and that gets carried squared all over g. This becomes your c. Now, at this point, I can say, okay, since I've been able to prove this way, I can have this start to represent as saying y equals to mx. Making x on the corner here, I should have divide both sides by m, divide both sides by m. Is it that true? Should it?
Yeah.
Or if I want to get my slope, if I want to get my slope is simply y over x. Is it that true? I can say divide both sides by x, divide both sides by x, whichever way, depending on what I'm doing. This will cancel. So let's keep the same approach here. I'll have h squared. Equals to 4 pi square h squared over g. Now divide both sides by h squared. Or you say multiply both sides by 1 over h squared. So I will do times 1 over h squared times 1 over h squared. So this, don't confuse this. Don't confuse this. This will take it. Then you see, then and this, I don't want to cancel that because I know that it's simply gives me my slope. So we have to apply those things. Somebody say, why did you do that? Because I know my slope is having h squared over h squared. So I will not cancel. So this is going to be sent as saying, let's have, so this is going to be sent as saying,
HT squared all over X squared is equal to 4 pi squared over G. Now, whatever you have here, this one is for your graph. See that? Whatever you have for your graph as your value must equal when you solve this thing. So if you get maybe 0.25 for your graph when you see the x over S, by the time you punch this thing, this value here, it must equal your graph. So that means that using this equation, mt squared over x squared is simply equal to 4 times 22 over 7 all squared divided by g is a constant 9.8. You see that on 10. In fact, you need to know that for your graph purposes, g always ranges from 9.54 down to 10.02. You need to know this. So anytime you solve for g, you get 10.02 or 50, you are correct. But naturally, you don't choose 9.8 for 10. So, alright, watch this for me. Yeah, whatever you have here should be the same slope you have on your graph. Watch it for me, what you have. So watch 4 times 22 divided by 7 squared, then take the division. So what this is simply is that once you see any equation of be it graph or whatever, I notice that there is an addition sign or subtraction sign here. First of all, what you have to think of before doing anything is to do the transform equation. That transform equation will give you the y, the slope, the x, and the intercept. Now from there, you're not comparing what you're doing. By a function. So if you want to finish this, we'll find the g as well. So what do you have? 4.03. So 4.03 like this. Now please remember, notice that everything we use here, see, this is 4, Chevy. This is 22 over 7. And please remember we're using 9.8, you see that, which is in meter, right? That means what we're using here is in meter. So this is simply in meter. And notice that we have this to be, if you take this 12 meter, second square over meter. So which means that if you finish punching this, you need to convert it to centimeters because of your own graph. I don't know if you're understanding it. Yes. What we are using here, we use 4. I is a constant. We solve it by doing the equation. So what we are using here is centimeters. So as the bottom 4.0, we convert this to centimeters now, times it by 100. Times this value by 100. Let's see what happens. See now, is it confusing? It's not confusing, Chevy. We got it in meter. So punch for me in centimeter. Now punch is by 3 times 100. 4.7 times 100. 4.7, Chevy. This is the answer in centimeter second square. Remember compare meter seconds over second square. So very important. Very important. So as over centimeter square, sorry, over centimeter square. And I know that this will take care of this. So that I have 403 in second square over centimeter. Please, your slope, when moving this, your slope must always have this thing. So actually it's here, this will take care of this. So that I have second square over meter. We plotted this equation we use for the meter. We converted it to centimeter. So this is your answer for slope. Now please, let's check if we are correct by finding G. Are you seeing it? Yes. We've gotten the slope. Let's now find G. Then we'll find K. You see? Error is slope. That one is the last part now when we use 4W over NR. Yes, we get it. You say we should do it. We will do it, don't worry. It's like you didn't attend our first class. That's why. Most of them are not afraid of them. But we get there, we can ask the question about one. Alright, please, can I clean this? I want to clean. So I can at this point say, let me make G subject of the formula. If I want to make G subject of the formula here, I will say, remember I have, from that slope, No, we want to get G. To find G, we want to determine G. So to determine G, I can say ft squared is equal to 4 pi squared x squared over G. Please, somebody wants to ask me, what of this G here? What of this G here? If you use this thing now, against this thing, notice that there is no other x squared here. Is it not true? And your graph is graph of x squared over x squared. Is it not true? So I'm using the one that represents x squared and x squared. That's why. So I'll just try to make this other on the board again. So let's do it. I'll say, if I divide both sides by x squared, I will have times 1 over x squared times 1 over x squared. So that this cancels x squared over x squared equals 4 pi squared over G. Is it not true? Yes, I can say if these two cross, you see that I'm left. Can you copy this? Please, if you are distracted, that's the noise. Please be fast. We need to be fast. Somebody wants to address you and I know you will soon have lectures. So we need to be fast. Can you snap it? So this is going to be sent as saying ELT squared is equal to 4 pi squared x squared. So we can have the divide both sides by so that I now have so that this I now have G is equal to 4 pi squared x squared over x squared. Alright. Alright, please watch. Notice something. Notice that your G now is the same as saying your G is now looking as it is. Equals 4 pi squared times x squared over xt squared. Are you noticing it? See, then I have x squared here, should be? And I have xt squared here for my G when I convert this. And everything here is looking as if it's the inverse of your slope. Shall we? Yes. So whatever we have as our slope, notice that our slope in centimeter, what did we get? 230, shall we? In centimeter, right? Yes. So this is the same thing as saying in terms of our slope, 1 over 430. So times 4 times 22 over 7 squared. I am wanting for the what we have. Notice that it's in centimeters. Watch for the what we have. Yeah, this is for me. So we have 4 times 22 over 7 take the square times 1 over 410. That is waiting after this one. Waiting after this one. What? 4 times 22 over 7, let's go times 1 over 410. My friend, watch this on the board for me. Let's see what you have. 4 times 22 over 7, straight times 1 over 410. 0.09. And notice the value we use is in what? Centimeter, right? Is it true? Yes. So the value we use is in centimeter. But now to take it to meter, what do we use? To take this to meter, what do we use? Is it divided by 100? Check well. Check well. Is it divided or multiplied? We're supposed to multiply by 100, right? Yes. So, Multiply by 100, let's see what you have. 9 point what? 9.8 times. Let's go what? 9.04. Are you sure? Something is missing because we are. I think our code is on units. Let's check. Let's be sure. I want to bring this. Our code is on conversion. If I have kilometer, I have hectometer, megameter, meter, decimeter, centimeter, and meter. So if I'm going this way, I divide. Divide. If I'm coming this way, I multiply. See that good? Yeah. So I am checking what we did wrong here. This one, see, let's do it individually. Our head square. Our head square is what? What did we get as our head square? What did we get as our head square? Let's do it individually. Our highest head square is what? So let's give us 9.8 from okay, please show me again. What did we get as our slope in centimeter? Our slope in centimeter, what did we get? What did we get as our slope in centimeter? 403, should we? 403 in centimeter per second, should we? See now? Then if you think about the we get 1.03. So I'm checking. Let's just check something. Let's say we are using in meter. Let's see what we have. So please watch this for me. Let's see what we have. Let's see what we have. Because we're having these problems. But please, I think we're having unit issue, so instead of confusing us, let's just use our meter. I see it. Let's just use our meter, please. Instead of using centimeter, naturally itself, if I'm calculating this, I don't use centimeter. I'm just using centimeter because of your graph. So let's just use our SI unit. So you punch it and you got 9.04 like this, which is approximately G is equal to 9.8. Is it not this? And this is meter. Please, instead of us using ourselves in trouble, let us always maintain what is the equation we are solving. Let us always maintain the SI unit, which is what? Meter. Instead of use centimeter, I want to find itself. So please, let's maintain our. So from here now, we can now say, okay, this is 9.8 meter now. Let's convert to the centimeter, which is what they gave in the graph. See that? Although that G is always faster, which is 9.8. So let's convert to centimeter. It's not going to be meter to centimeter. It's going to be 100. So this side is multiplied. So I have 9.8. But nobody will ever ask you to convert gravity to centimeter. I see it. Yes. So please, have it in mind that this is how to find your G. G must always be constant. Another thing that I can ask you to find is to find K. Because for next question, you know that we have K. So if you want to find K, I already gave you a formula for K, which is L over root 12. Should we? Yeah. But from our equation given to us, we can also find K by doing. We can also find K by doing. We know that over G. Right, this is it. So once you get K now, you can also get K by this. Please, why are you doing this to find my G? Do it that G gets this. Once you get this, but why are you doing this to find my G? I can give you a scope of 8 student. I guess it's that's why. So to take K now, so let me make it right then, because I have G8 student. 4 by square. So now that J square equals to G8 square over 4 pi square. So I can say, take the square root of both sides and this is cancel. Take the square root of both sides. So please, if I want to find J now, you see that I am having J is equals to square root of G8 square over 4 pi square, which means that K is equals to my G is 9.8, 9.8. Then my head, what's the highest height there? But you see, I think let's do this. Our head is what's my head is straight? Yeah? What is my head is straight? What? Check now. How I'm teaching human beings? I'm teaching people that are just coming. 3. But the next one for my head is straight. What? That is on this side. What? Check. Just check what you have here. And we did this thing now when we started. We did something of our reading. Then we got something for 80 square. This side, you see now? Give me that value that we got for 80 square. That first value. Give it to me. Can you hear me? I said that value we got for 80 square. That time the first value. It's true, right? That time we started, I gave you reading, so you didn't copy it. There's a place where we did H times D square, we got 80 square. So give me the value for that 80 square, that first value. What do you get? 3 to 8.5. 3 to 8. So let's use our code. I have one for me. What did I put in here? Get an answer. So please, can I claim this? Yes. One. Since you did not copy that one. Some of you don't want to copy it because in your mind you are saying you already have your own. But this one we are doing is much more correct. Anything that has to do with practical or graph, the most correct is when you are able to learn how to use the formula, the equation for that particular practical to find period. Then you now use the practical formula for period to this period equals to T over N to find the small time. So please, watch this thing. What do you have for everything here? So 9 points. 0 to 6. Okay, and this is a centimeter. Okay, this is a meter, sorry. This is a meter. Remember, this is our value. So please, if we convert this to centimeter, then we'll times by 100. It's not good. And so by the time we times this by 100, you get what? 9.2. So please, let's allow that to go. Please, this I'm not sure of it because it's not the final. I need us to check for my own value. But let's allow that to go. Once we finish, we'll continue. So we'll continue with solving the question of conclusion. I get the conclusion yesterday, but I'll still mention it again. Then the person that said, what does your represents, yes, it does not represent meter rule. Some of you are writing meter rule. It represents the axis of gyration. Meter rule axis of gyration. It represents the meter rule axis of gyration. It represents the meter rule axis of gyration. So once it's done, continue. Big man. You came late. So once it's done, we'll continue. Good morning, students. Please, if you want to know if you are correct, notice that when we did that our sheet, we gave us 4 5 square over 5 to our slope. So go ahead and write so that you need to solve it will go from 9.48. So if you want somebody might solve and the G is not giving you 9.48, you must be wrong. Yes, G is a constant. And that is why I know that anything physics is hard for you to manipulate the physics. Because once you get into the physics, you must have something that will get you. So if you are getting a slope, that by the time you solve for G, it's not giving you 9.8. That means you are wrong. So please, I think the only thing I've not answered is how to find error in slope and conclusion. For the conclusion part, just tell them that anything compound pendulum is testing or giving for anything. One is to determine what is the way to start achieving from the question of the question step will give you a conclusion. But the question we have is equals 2 pi root x squared plus a squared all over gh. So for this question we can get the conclusion. The first is that the fundamental helps us find the moment of inertia. That is 1. 2 is to determine the center of gravity or determine acceleration to gravity. That is 2. 3 is to determine moment of inertia. That is 3. It is going forward before the touch is to determine the K. That is the axis of rotation. So 4 things. 1 to determine G. Gravity. 2 to determine your axis of rotation, which is scale. 3 moment of inertia. And 4 I said something about going forward determining so I think I'm going to start. First, number 1, axis of rotation, which is scale. Determine axis of rotation. 2 determine center of gravity. So see all this transaction from here. So my height is displacement. Now, please, for the last part, for the part that is remaining, which is error is slow. Even if they do not tell me to find error is slow, normally use FG equals to 4W all over NA and take the formula of the please, can you be quiet? Please, be quiet. So when you are just coming, you do not do the math on the graph. You just rush to collect and come in. As you are coming, you are still asking questions. You stop the person you are talking to. You know that some people are just enjoying. If they are saying too much time, you say they are not good. Yes. Once you are talking, on some topic, they are not happy. So please, be quiet so you can solve it. All right. y axis. At least this is actually a then this is very square. Now let's say this is my line of best fit. Something of this nature, let's say it goes this way. Now let's say this as a point fixed by this. Another name for this line of best fit is what? I said it in our last class. I want to test people that they got class. What's another name for line of best fit? Saturday class students. What's another name for line of best fit? Line of regression. One. I said another thing again. I said regression, not progression. What you imagine? You see, some people come for Saturday class. After coming for that class, they go on close to. Please, we also see that the next kind of limits. Please, if you are going to see, let's say if I have points of this, let's say I have points that do not enter this. These points that do not enter this line is what we use to check vertical scatter. How do I check it? I want to ask myself, between these 2 points now, which one is closer to this line of best fit? This one. What about this one? This side, on this down part, this one is closer than this one, Shelly. I will just come and draw line. It's not why I have this line. I just draw this line that will pass through this. This is my third one. I take this like this. Straight. Now, the same thing here. Right. Straight. Just straight line. The minute I finish drawing this, I'll have to draw vertical lines. At any point of this, I'll come and draw. I like to read here. I'll come and draw vertical lines. I'll pass through this. The minute I get this vertical line, what I'm doing is so that I have to place the measurement to my vertical axis. So I'll have to place this measurement. Let's say the measurement I have is like 10. Anything I draw. Let's say when I draw this one. Let's say what I have is like 2. Anything I draw, I'll get it for you. So I will then come and say, 3 minus 2 is what? 1, Chevy. That is minus 2 is going to be 1. If you do your own, you can give it let's 4 or 5 or something. It doesn't matter the point. Because anything happening here is convenient. Whatever money you get, you like that, so that you forget. Give you the same. If I get 5, I get 4. 5 minus 4, 1. So the main thing is knowing how to get this. Those points that went out, that is what we come back to. So by the time you just project it, you got it on. Any is the number of observation. So you ask yourself, in the practical you just finished, how many of these did you take? How many things did you do? So you check the serial number. Kind of serial number determines the number of observation. So how many serial numbers do we have? It's not even every time they give you serial number. So you just know that the number of things you have got, that's your end. So my end is like this. Now, arrow is what we call range. So I'm not anything that just put to the center axis. So I'll simply ask myself, the highest value, what is the highest value on the horizontal axis? And what is the lowest value on the horizontal axis? Can you hear me? Yes. So if you want to make it easy for yourself, you know that on the horizontal axis is is it not true? Now check those readings that you use for your graph. On your own head square, what is the highest value for the head square? Maybe for some people it might be 0.09. For some people it can be something. So whatever highest value you have here, then check the lowest value, whatever it is minus 6. So that becomes your R. So R is the highest horizontal value. Minus lowest horizontal. So whatever you have, let's say you do your own. Let's say you got your highest value here, but your rating is like 2. Your lowest one, sorry, let's say it's 4. Your lowest is maybe 2. It's different from, it will be different for different persons. So whatever you get, so now for the person. So once you get this, like, come and call this. So let's say 4 times 1 all over my end is times 2. Whatever it is your error. I say But I'm using for yourself, you always need to my worship. And this particular compound pendulum, it is always a graph of acceleration mass, which is second square over centimeter in this case. Whatever is second square over meter. So I think you are taking centimeter, it's going to be second square over centimeter. So compound pendulum in summary. So please, in summary, over your conclusion. In summary, over your conclusion, you said that it is a practical that determines the physical properties. It's a practical that determines the physical properties of things like acceleration, velocity, and displacement. Alright, that's the question. I said, I should repeat. Range. Okay, range. Okay, I will repeat. I said, it's a practical that determines the physical properties of acceleration, velocity, and displacement. The physical properties of acceleration, velocity, and displacement. They ask what does your scope So, for range, the person that asked me to repeat this range, I said, check your own head square. Check your head square. What is your highest value for head square? Just tell me your value for it. Yes, on your head square part, what is your highest value? 25. 2025. That's your highest value. What is your lowest value? 100. You will do 2025 minus 100. Anything that is a range is your range. Can I see it? Yes. So for you now, so highest minus. So please, for today, that's the noise. I will allow you to do your practical. So please, still remember everything we've done today and go through the readings when we started. Yes, how I taught you how to do this. You can maintain the readings given in the book. But on the second book, you are analyzing what you're doing with the one I gave you.
Let me contact you. You don't see the camera for you.
So when you finish, yes, so that's your point. Please, make sure you're doing this important. Whatever you're doing, that's what you're doing. Okay, please, if today is your first time, my number is 090. If today is your first time, my number is 2071-42. Yes, academic, So if today is your first time, 2071-40. Please, there's a habit that this hall, we have a habit in this hall, please. We have a culture in this hall. This hall is not supposed to be noisy. Please, then ask questions. Are there any noise in the hall now? This is the one hall, that's why they call it hall B. This is one hall that if people are passing, they are wondering what is happening here. Everybody passing around on campus know that this is where all the science students are. So please, there is a culture to this hall. Don't come here maybe the way you did in jam class in your secondary school. You come and want to do it here. No. Whatever you're doing, do it calmly in this hall. Please. So if you have any confusion after the class, you can just come and meet me. I put you through. But save my number, message me. The minute you message me, you get an auto reply to the group chat so that you can join the group. So for the last time, my number is 790 2071-42 academic diary of academics. If you've not gotten documents for filing, any of those documents, you can also come and meet me. I'll be at the back. And try and come for tutorials. Immediately you finish lecture today, we are going for our tutorial class. No, it's not correct. The rate is not correct. I don't know who is teaching you this, but once it's horizontal, yeah, and that horizontal, see, let me just.
All right, get the first question and answer, then you get the lab book.
I'm coming.